Hey everybody, welcome back to day 2 of Figchella, also known as config to some of y'all.
Hello everybody, I hope you don't mind me wearing the same confit as yesterday.
When you look as fabulous as you do, it's okay, I'll allow it. It's lovely for all of you to join us, and to all of you joining us remotely, we're glad to have you here in spirit.
My name is Isaac Goldberg, and I'm a software engineer here at Figma.
And my name is Majola Balogun, and I'm also a software engineer at Figma.
A fun fact, Majola and I actually met singing in the Figma a cappella group. Now, yesterday we didn't get a real chance to, give a real performance, so what do you say we give it another go?
Not this again.
No, come on, let's give the audience what they came here to see. Come on. Here's your note.
I don't know about that.
All right, well, we'll save our performance for next year. But first, let's get ready for some talks, right?
That's right.
All right, so please turn off your phones, and let's be an incredible audience for all these great speakers.
All right, first up, I'd like to introduce you all to a true archaeologist of interfaces, a scholar of design affordances, a wizard, a bona fide cursor magician, Johannes Mutter. Please join me in welcoming him.
Good morning, config. Thank you. My name is Johannes, and as a design engineer, I've been collecting interfaces and disassembling them for around 15 years. I named them and I classified them, every mechanism that I find on Twitter or other platforms. I took note about how they work and why they mattered. But outside that library that I created, it surprised me that how little shared vocabulary we have in interface design, in the patterns we use. I wondered, why is that? Why is there no a pattern language for interfaces, an interconnected library of the named reusable components great tools are built from? Architecture has a pattern language. It was written by Christopher Alexander. No, not working. There we go. Perhaps interface design has no pattern language because we could hand off the naming to the engineers, right? You could just skip the layering, but if you did the layering, I think the naming of the layering, kudos to you, because in 2026, I think it's paying back. Because knowing how to articulate your designs in words is just as important as shaping the visual material. Yesterday, if you have seen the talk by Chelsea from Anthropic, she said it also very well, language is design. Now let me show you a glimpse into the pattern language that I have built. This February, I shared an early prototype on Twitter. I named it Interface Lineage, and I didn't expect much from it first, but it just blew up. I walked back from kindergarten, bringing my kids to the kids, and looked on my phone and was like, oh my God, what's happening here? So I felt like there's a real need for maybe a pattern language. And what I did is I modeled all these patterns as a living organism. I modeled in them what came before, what inspired it, what contrasts with it. And this presentation you're seeing is an evolved version of that early prototype. Every example is pulled live from the library. So this presentation is interactive in itself. So where these patterns, they exist also in this library as little teardown stories, and we'll get to that later. I'll start this talk with one example, then I share a little bit about my design philosophy, followed by these 3 design moves, and finally a demo where I'll show you my method of disassembling interfaces, something that goes beyond mere bookmarking. Let's do a quick experiment. Please look very carefully. I'm going to move one step to the side. Can you guess which direction I will move? Left or right? Did you notice my signal? A blinking cursor standing on the seam between a regular word and a bold word has the same problem. It can't guess direction. So it can't warn you whether the next keystroke will be bold or not. But if you give it this tiny pixel tail on the top, it can warn you. I felt that pain 1,000 times in Slack when I wrote like code and prose in the same line, and then I wanted to write code, but then it turned out to be bold. But I did not notice this pain consciously. Also, I never had a word for it. But a designer named Yoshiki Schmitz, he noticed it. And 2 years later, a text editor called Bike implemented this idea. And it was given a name on Hacker News called cursor affinity. Noticing and naming were the 2 moves that led to this innovative micro-interaction. And the moment you have the name and you have seen the connections to related ideas, your brain does this incredible thing that you can see the whole family it belongs to. Because cursor affinity, that is just a tiny trail in a larger map of decisions thinking about how to render a cursor. Jeff Raskin, the author of the book The Human Interface, he wrote about it. And the I-beam, which you can see here on the left, in Xerox Star, it showed text direction when you hovered over Latin or Arabic text, something that is lost in modern operating systems. So every one of those inherited from the one before. Nobody starts from 0. Even something as the magical AI cursor, which we've also seen yesterday in the OpenAI talk, in Codex, is standing on the shoulders of giants. Kirby Ferguson, the maker of the Everything is a Remix series, said it about songs and films. Bruce Lee said it about kata. You steal the move, then you make it yours. I'm here to say it about interfaces. Nothing is original. Originality is recognition, not invention. All design is redesign. And Hofstadter, a German philosopher, he went even further. He said, like, analogy isn't a trick of thought, it is thought. You can only think with what you've already seen. But seeing is not enough either. You also need to name the move, the pattern, the mechanism. And you can triangulate from known concepts. So cursor affinity, you can triangulate it from the idea that a cursor has a body, that it can change direction, that it can look around. So we'll now look at 3 such iconic moves in interface design. The first one is about design indicators that to make invisible state visible. The second one is how to forgive imprecise input by humans, because we humans, we are not precise at all. And the third one is about how to reveal hidden actions. So let's dive in. This is iChat in 2002. I don't know if you remember, but they already had these lovely thinking clouds that would show up as you typed. And it's a tiny pixel of invisible state, so you don't angrily double text and you wait. You can notice, okay, the other person is doing something, maybe I wait a little bit. Here in VS Code and in Apple Pages, you see the same move. Notice the dot after the file name and the edited in the title bar. The system knows you have unsaved work, and it spends 1 pixel telling you. And once you know this pattern, you see it everywhere. In the doc for the running doc indicator, or in Claude, where it renders these lovely thinking indicators. My favorite label was waffling. Your phone does a more honest version of this. So it shows you a friendly compression of real-time radio physics in just these 4 little bars there over there. And I love all these tiny micro-interactions because they don't sprout out a separate spinner just to show progress, right? The state and the affordance are the same pixel. So that was move 1. When the system knows what the user can't see, mistakes multiply. So when you design an interface, find that hidden state and design a 1-pixel signal for it. So move 1 was about what the system should show you, and move 2 is going the opposite direction, what you can tell the system. And your hand, remember, it's not precise. Quick show of hands. Who here has clicked in anger when a menu closed and you were trying to reach diagonally? Right, like, super frustrating. And the Mac team in the mid-80s, they solved that in the 80s with this invisible triangle from your cursor. But if you open Google Maps or there's tons of applications, and you do that, and you find yourself, no, it ignores my intention. But if you stay inside with your cursor in that triangle and someone cared about this interface and cared about implementing the safe triangle, you will have a good experience. So the next one, this one's quite magical. I don't know if you have ever noticed this, but the keyboard on your touchscreen, when you type, it guesses the next probable word you're writing, and it guesses the next likely letter you're going to write. And then it invisibly grows the hitbox around your key. So you're less likely to hit a letter that you didn't intend to. And the version 1, which you can apply in your designs, is maximize your hitboxes of your buttons, of your controls, of your menus, not the visible surface, the hitbox. So if you have gaps around and margins and so on, fill them as well with the hitbox. Growing the size of a button has its origin in the dock, designed by Baz Aldrin from Apple in 2001. The icons swell as you approach, and they make it easier to hit the target. Fun fact, the Finder icon has its origin in a Picasso painting. Snapping is cursor magnetism, but for objects. So cursor magnetism pulled the pointer toward a target. Snapping does it to whatever you're dragging. You aim it roughly, and the system infers the line you meant. It absorbs the slop. The guides, they're just feedback. The correction already happened underneath. Ted Selker, he asked the wildest version of this question. What if the hand doesn't move at all? Force instead of displacement. And the idea of the red trackball in a Lenovo ThinkPad, if you've seen that little knob on the keyboard, that lives on in every keyboard today on a touchscreen. You long press the spacebar, and then you can precisely move your cursor. So here's the takeaway. Forgive imprecise input. The pointer is a rough guess at intent. It's not a precise pixel. Infer what you meant, what the user meant, and absorb the slop. And please do it in software and hardware, but never make the user absorb the slop. So move 1 was what the system shows you. Move 2, what you tell it. And move 3 now is what you even allowed to do, because most power in an interface is hidden until something reveals it. The add symbol is keep getting reinvented. I think just 2 days ago or so, when Claude launched Claude Tag, we've seen another iteration of what the add symbol is. But you see it on email, in Twitter, in Slack, and GitHub. You type it, and the menu shows you what's in reach. Followers, your files in the cursor project, or here in Doki, which is a lovely text-based video editor, you can add the script, and you can add characters to your script. So if you think of the add symbol as the noun, then the slash is the verb. Remember, a good interface disappears the moment it works. The slash is how a toolbar disappears. You find this pattern in Notion, in Linear. Every command tucked away behind one keystroke. It's only there if you ask for it. And there's 2 principles here. The first one I want to name is progressive disclosure. One trigger, the full set of command on demand. And the second one is recognition over recall. You don't memorize the command. You only recognize it in the list when you need it. So Markdown, that even drops the list. You type a hashtag, and it becomes a heading. You type this bracket character, and it becomes a quote. A dash becomes a list. So no menu, nothing to recognize. Markdown is pure recall. It only works if you already know the symbol. The character is the command. So up to here, the trigger was a character you type, add, slash, hashtag, whatever. Now it's a gesture. And a gesture can do something a symbol can't. It can teach itself. So I don't know how you learned this, but I was shaking my phone, and I was like, what did you do? And then this pop-up came up and said, do you want to undo? And that's an extraordinary experience of teaching an interface mechanism, because this experience makes it stick. So slide to unlock teaches itself too, but on purpose. That little shimmer, well, we don't have it now anymore, but that was the interface, giving you a gentle hint what you should do. Now take the same principle and apply it to a list item, and it unlocks the actions hiding underneath. And the nice part is, if you notice this pattern, and you take the same swipe, and instead of turning it to the individual list item, but you apply it to the entire list container, and you just flip it 90 degrees, what do you get? You get pull to refresh. The same gesture, just rotated, rescoped. So a takeaway I want to give you here is like, if you separate the visual experience, the visual material from the mechanisms in interfaces that you use every day, and you then look at the mechanism itself, you can translate that and apply that in various different conceptual spaces. So this is like a cheat code to inventing new interfaces. So that was move 3. People don't know what they can do until you show them. So surface them the action the moment they need it, and not before. So we have seen now a handful of mechanisms, but how do we uncover them? I think not by bookmarking, because a bookmark, to me, is like a frictionless experience. It's designed to be frictionless. You hit save, and it feels done. You feel great, right? Like, I externalized this, and I know it's there, and I can find it again. But understanding needs the opposite. It needs friction. So let me show you what I actually do when I find an interface that catches my eye, and what it's like to walk through my project interface lineage. So let's go into a demo. So this interface caught my eye this morning on Twitter. You see watch the hands, so like it pulls a sentence and it grows, and you press it and it shrinks, and the words, they are not resized, they are rewritten. And it reminds me of a similar interface. Let me pull that up quickly. So this is my text editor here in the presentation. It was called Texterial. Here we have it. So this is a very similar interface from Jocelyn Shen at Microsoft Research. So they thought about what if text is shaped like clay? You know, like you can move text together, and it really behaves like clay. You can reshape, you can combine, you can summarize, you can expand, really like a piece of clay. So what I do when I find an interface like that, or a collection of interfaces, I first capture what I think about it. So let me just dictate here. So Texterial is a writing tool where text behaves like a material, by Jocelyn Shen and her collaborators at Microsoft Research. You pull a paragraph, and it gets longer. You pinch it, and it gets shorter. The gesture and the edit are the same move. And I have that. And now what I would usually do is I would look at the interface again and try to understand, like, what are the components here? What do I see here? OK, let me dictate this again. I see pinch to condense, pull to elaborate. The gesture is the command, and the text is real-time generated using a large language model. Now I would go on and do some more deep research. I would look like what other work have they created, what is related to it. But for the sake of the demo, I will just show you like what I would do when I want to explore the network of this idea. So I have a command here which is called lineage grid, and what this does is when I type it, it looks at the entire graph of all the thousands of interfaces, principles, and patterns, and it tries to match what is related to this. So let's add this here, and I will just hit save quickly. Now I can explore what is around this. So here we have the author, we have a principle, we have a pattern, expand in place, and disclosure. Weird name, what is this? OK. If I want to learn more about this, I can now dive in and see, OK, I can read the description, and I can also go into examples that embody this pattern. Telescopic text is, for example, one. So this is very similar to the one we've seen before, but this is like curated, right? Like someone made these texts before. It's not generated by an AI interface. Oops, yeah. Let's go back here. Yeah, and so there's other interesting interfaces we can explore which have the same principle, liquid text. It lets you read 2 sections of a text in parallel by squinching the screen. Or Euterpen, it does it the other way around. You know, like as a music composer, you might need to add a lot of nodes, try out things, and if you do it on top of the nodes, it will get very messy. So they invented this mechanism of expanding the space between the nodes. But I will leave it here. Let's go back to the slides. Because what is this method? This method that I use has 4 steps. You see it. You see something on Twitter. You see something on Twitter, like on Instagram or in your work from your colleagues. And then you notice it, right? Like you look closely, what's happening here. And then what you need to do is you name it. You say like, this is pinch to condense, this is pull to elaborate. And now you have the words. And after that, you link it. The grid I put in, there was the lineage. I can see where it came from, what is related to it. And after that, what I do is I steal it. Because now I can use that move in my own work. I can prompt for it because I can name it. I can ask Claude and Codex to connect to my library and say, hey, can you please research more about this and understand this pattern? I want to apply this in my own work. So why does this actually all matter? When the machine can build anything that you want, and it can make 1,000 versions of it, what matters is your words, because they become the bottleneck to what you can express. So what I'm saying is always, you cannot prompt what you can't name. And interface lineage exists to help you with the names, to find these patterns. So 3 things before I go. 1, you can browse hundreds of these patterns and principles on interfacelineage.com. You can scan the code. You can find me on social media. My name is Johannes Mutter. And if you would like to disassemble interfaces, you can find me on the picnic tomorrow, I think, tomorrow morning at Alamo Square Park. And we can sit in the grass and then do some interface disassembly. So thank you a lot for listening, and I hope you have a great day here at Config.